Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope you are doing well. And wow, what headlines happened this week. Isn't that crazy stuff? But hey, we're not here to talk about those, whatever they may be. We're here to talk about nice, fun, uplifting stories that you probably haven't heard about, because we definitely didn't talk about these on the show yet, and you probably should hear about. They're always fun. We're going to talk about them with Ralph Bond, who we'll bring on in just a moment. But before that, computeramerica.com. It will have everything that you need for today's show and really all of our shows. You can go there, you can find the show notes, and you can find the video archive, the audio archive, wherever podcasts are heard. And of course, you will find links to all stories and material. So with that being said, let's go ahead and bring Ralph on, and we'll just have fun with it. We'll have a nice, relaxing Friday. So everyone, welcome back onto the program. Once again, Ralph Bond. Ralph, how you been?
Great, and we have some great stories today. In my role as science and tech trends correspondent for the show, what we do every Friday is look at where we're headed. Most of the stories are early research, where we're headed in things like artificial intelligence, no surprise, robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. It's all open for us to check out. And we're going to give you, here's the key, we're going to give you an oasis of positive news, thanks to the world of science and technology.
Absolutely. And I think story number one is, I don't know anyone out there if you've kind of been noticing all these useless micro vibrations and you're like, wow, why can't these things be useful? Really, story number one highlights the kind of stories that, you're going to hear about a lot of the bad news, sad news. You're going to hear a lot about, conflict and all that good stuff. But, research matters, and research getting attention matters. We've talked to a lot of professors, a lot of grad students here on the program over the years.
Yeah.
And, Ralph, like one of the hardest parts, and this is really what MIT and Harvard does better than a lot of other universities. It's not that, they're more prestigious and they have, whatever, but they're not like better innately. They have the same access to information as everyone else does. It's, publicly viewed. It's whatever, Ralph, but it's really the publicity, the amount of attention these students can give their research, and it's happening all over the world. Yes. Amazing breakthroughs that just need attention. And I really appreciate that you come on the show and really highlight research, because it does help these people, kind of make careers and make innovations. So story number one, great way to highlight that. And hey, energy generation. It's always top of mind. Story number one is going to be a little bit different though.
Yeah. So again, come out to computeramerica.com, get the show notes, because what we do is I pull 4 stories that I find interesting, give the highlights, but I have links, pictures, added information, and so forth that you can come back and check out. If you're listening to us as a podcast, that's particularly important. If you're lucky enough to be watching us as a video, you'll see the images and so on. But this first story comes from newswise.com, and the headline, Harvesting unused micro vibration to generate electricity. Ben, it's a great example. We've talked for many years now about all these different ways people are trying to find out clever ways to generate electricity. And we're going to get there. We're going to have a world someday where almost everything you touch and do is going to generate energy, which will solve a lot of our problems. But again, come out to computeramerica.com, get the show notes. So here we go. The Korea Research Institute of Standards and Science has developed a metamaterial that traps and amplifies microvibrations in small areas. And this innovation is expected to increase the power output of energy harvesting, which converts wasted vibration energy into electricity and accelerate its commercialization. So this is a whole world I hadn't thought about. We all know about energy harvesting, but the idea of harvesting energy from vibrations to then in turn generate electricity, this was kind of a new world for me. But time out, and this is where I add value in the show notes. What is a metamaterial? Because the author of the article assumes you know. Well, a metamaterial is an artificially structured material engineered to have properties that are rarely observed in naturally occurring materials. And then, wait a minute, side note, what are micro vibrations? All right, micro vibrations refer to low-level mechanical vibrations or disturbances that typically occur at frequencies ranging from less than 1 hertz to 1 kilohertz. A little bit geeky here, but that's what we're talking about. And then further, a little more added value to the show notes, micro vibrations can be caused by a variety of factors depending on the context. And here are some common sources, not the only ones, but here's kind of like the greatest hits of micro vibrations. So mechanical components in machinery and electronic devices, micro vibrations can be caused by moving parts such as motors, fans, and gears. Environmental factors, external sources like sound waves, seismic activity, or even nearby traffic can induce micro vibrations. My brain is just like spinning around when you think about something like traffic.
Lots of possibilities.
Oh, yeah. And then thermal effects, changes in temperature can cause materials to expand or contract, leading to micro vibrations. So there's the world of micro vibrations. Pretty cool stuff.
Yeah.
As noted a moment ago, energy harvesting refers to technology that converts wasted energy in the form of heat, light, and vibration into electrical energy. And again, we're going to be talking about vibration. And the article makes this point. It says, while solar power generation, which utilizes sunlight as its energy source, is used commonly, it poses limitations such as inconsistent output and the inability to generate power under certain weather and terrain conditions. We all know about the limitations of solar panels, correct? Now, this is why the science community is so interested in microvibrations. In contrast, using ubiquitous vibrations as an energy source enables stable power generation without surrounding environmental constraints. Pretty appealing. This is why vibration energy harvesting continues to gain attention as a future source of power, for example, for sensors that require a constant 24/7 power supply and wearable medical devices that could measure blood pressure, for example, and sugar levels in real time. So the key here is not environmentally dependent in terms of is the sun shining or not, is the wind in the right position? Nope, this is all going to be, if you have consistent vibration source, you could be generating power for sensors 24/7. That's the key.
For a lot of the geeky people here, I think that a lot of the idea of like wasted energy goes off in heat. And figure out how to capture that heat, reuse that heat, and heck, we generate a lot of electricity using heat. But vibration, I guess, as a way to kind of describe another form of wasted energy, I never really put two and two together. So that this is a very enlightening article, and the fact that they're even working on that makes sense.
Yeah, and being we're in the summertime right now, off in the distance in one of my rooms, I have a fan that's going pretty much 24/7. Well, what if this thing was coated with this material that's the vibrating from the fan motion, generating electricity to self-run the fan? I mean, maybe. Who
Yeah, no.
knows?
So even something as small as just taking it from 64 watts to 63 watts, to run or
Yeah.
whatever it may
Yeah.
be. Just little improvements for sure.
Yeah. So going on here with the story, the metamaterial developed by the Korea Research Institute of Standards and Science traps and accumulates micro vibrations within it and amplifies them by more than 45 times. So it's not only sensing the vibrations, it's amplifying them. Pretty interesting. This allows the generation of large scale electrical power, large scale, take that with a grain of salt, because we're talking about very small things here. This allows the generation of large scale electrical power relative to the small number of piezoelectric elements that are utilized. Timeout reminder. Piezoelectricity refers to the electric charge that accumulates in certain solid materials such as crystals, ceramics, and biological matter when subjected to mechanical stress. A little bit geeky there, but that's what
Hmm.
piezoelectricity is all about. Now, the newly developed metamaterial has a thin, flat structure, roughly the size of an adult's palm, allowing it to be easily attached to any surface where vibration occurs, like my fan fantasy I mentioned a few
Hmm.
minutes ago. Applications range from diagnostic sensors that check for damage in high rise buildings or large bridges to small biosensors that monitor health conditions of individuals. Wow, the potential here, Ben, is just staggering.
Very,
I
very
love
early
it.
stuff, and obviously they're gonna
Hmm.
have to miniaturize this a lot, but still,
Yeah.
it's a very interesting way because we've talked about a number of different ways that you can run medical devices in people's bodies without having to take them out, replace them, do things like that. This could just be
Right.
another additional thing that you could put in that maybe, let's say you have a pacemaker or a sense, or like they said, like a glucose sensor. Hey, maybe you don't have to get it replaced every 2 years. Maybe it might
Right.
last 10, 15, 20 years with a
Right.
reliable power source. So
Yeah.
very, very cool. And hey, could change people's lives. Story number one. Story number two. We're going to go ahead
Yes.
and jump on over to another plastic story. And,
Yes.
as we've done a few of them recently, but
Yes.
it's good to see, Ralph, that plastic is a known problem, and we've known about it for a long time. Getting solutions out into the market is difficult, but we need a lot. We need a ton of solutions and just pick from the best. And this is another
Yes.
solution. Maybe the best, may not be, but hey, it's a step in the right direction. So story number two is all about plastic.
Yes. And this, again, to your point, we've had over the many years loads and loads and loads of research all over the world, 24/7, going on about how can we replace plastic, the bugaboo of plastic, with something that's biodegradable and ideally sourced from agricultural waste. And this story kind of fits in that category. It comes from phys.org, which is short for physics.org. Headline: Researchers invent 100% biodegradable barley plastic. Wow. And again, you can get the show notes and learn all about this and could dive deep into the recipe, as it were, of how they pulled this off. But here we go. A bio-friendly new material made from barley starch blended with fiber from sugar beet waste gives you a strong material that turns into compost should it end up in nature. And this has been created at the University of Copenhagen. Wow. And the researchers at the university, at their Department of Plant and Environmental Sciences, have invented a new material made from modified starch that can be completely decomposed in nature. And get this, decomposed within only 2 months. Wow.
That beats traditional plastic by a few hundred years.
Yes.
That's really
By
impressive.
thousands of years. One of the key researchers noted, quote, "We've developed a new type of bioplastic that is stronger and can better withstand water than current bioplastics. At the same time, our material is 100% biodegradable and can be converted into compost by microorganisms." So that's the mechanics of how it gets decomposed, but in only 2 months. I love that. The new material is so-called biocomposite and composed of several different substances that decompose naturally. Its main ingredients, amylose, amylose, I hope I'm saying that right, and cellulose are common across the plant kingdom. Amylose is extracted from many crops, including corn, potatoes, wheat, and in this case, barley. The research team has founded a spin-off company in which they developed a barley variety that produces pure amylose in its kernels. The researchers further noted, quote, amylose and cellulose form long, strong molecular chains. Combining them has allowed us to create a durable, flexible material that has the potential, the early research folks, has the potential to be used for shopping bags and the packaging of goods that we now wrap in plastic. So great, encouraging development. Again, I stress there's a world of work on bioplastics out there, and this is a new and latest installment. But again, 2 months to degrade in nature if it's thrown in the landfill. Wow, I love it.
And I guess the part that I like about this is that you can see from the picture up on the screen, like after like a week in the elements, which doesn't seem like a lot, but Ralph, I guess like the part that plastic has to do is it has to stay, if it's stable, shelf stable, and if it's holding something that we're still trying to use, it has to stay, not decomposing.
Yeah.
But once it's out in the elements, though, like it keeps its form for about a week. I would say it's still pretty good, although, but like a week out in the elements, that's pretty good. And obviously, this is probably ideal, like, microorganisms decomposing and stuff like that. Right. I like how long it lasts. But then, of course, after 2 months, it's almost completely gone, which is the ideal.
Isn't that wonderful?
Plastic. So I like that a lot.
Very cool. And once again, friends, if you're listening to us as a podcast, we were talking about this wonderful image from the article. Please come out to computeramerica.com, get the show notes, get the links, see the images as a follow-up, and you won't be disappointed.
Absolutely. So there you go. Story number 2, story number 3. And, Ralph, I always heard that when I don't know if like when you fly, like the pilots kind of come out of the cockpit when they've landed and, they kind of sit there and watch the people, disembark. Yes. I've always heard that you should compliment a pilot, and if you want to, you don't say good flight, whatever, because honestly they barely touch the controls when they're at cruising altitude and whatnot. Ralph, if you really want to make a pilot feel special, you tell them nice landing or nice takeoff, because that's the part that pilots do pretty much by hand. And there's some computer aided systems that help, but that's where a pilot really kind of has to do their thing the most. Well, hey, maybe the computer might get those compliments here in the near future, because this is an automatic takeoff for, I'm sure you're going to explain this, what an E2 family of aircraft are, but hey, computers are just getting that much better. So we haven't figured out self-driving cars, but maybe we'll figure out self-driving planes faster. So story number 3.
Yeah. So story number 3 is all about a Brazilian aircraft manufacturer. And I do hope I'm pronouncing this correctly. I did a search to try to learn how to do it. Embraer. I hope I'm saying that right. And the headline here is Brazilian aircraft manufacturer Embraer introduces automatic takeoffs for its E2 family of aircraft. And I got this story from Aviation Week. And believe me, Aviation Week assumes all their jargon and so forth, understandably. So in the show notes, I've inserted some tutorials to help me and maybe you fully appreciate what's going on here. So auto landing software and systems have been a standard capability for decades in the aircraft industry. So auto landing, things that assist. Now, that doesn't mean the pilot goes to sleep and just wakes up, we're here in Portland now, I'll just get off the plane. No. That's not what we're talking about. You always still have the pilot and co-pilot able to intervene if the landing system is a little out of whack or something like that. So I don't want to overemphasize the auto landing part of it. But the key point is auto landing software has been around for a while. But Brazilian aircraft maker Embraer is the first aircraft manufacturer to develop software that allows for automatic takeoffs. That's the key here. That's kind of like the drum roll ta-da in the aviation industry. So Embraer is introducing its automatic takeoff function for its E2 family of passenger jets, leading to much enhanced range abilities from short runways. So there's a lot of airports like here. I live in Hillsboro, Oregon. We have a small regional airport just a couple miles from here. And of course, its landing strip and takeoff and landing strip is short compared to something like at the Portland International Airport, of course. And so this is opening up the possibility for jet aircraft, larger aircraft, pardon me, to use shorter runways, which is kind of cool. And the function called the Embraer takeoff system will be available starting the fourth quarter of 2025 and will also be available for retrofit on aircraft that already have been delivered. So that's kind of a fun point. This new technology can be retrofit.
Yeah, that's certainly good because aircraft, they stay in circulation. They stay in use for 20, 30 years at a time. So retrofitting is important.
Yeah. And it says the Brazilian manufacturer's design claims to improve rotation and I can't say it, trajectory. Friday morning, I can't say it. Reduce field length and lessen pilot workload. Other than a software update, no aircraft modifications are required, which I think is just wonderful for deployment. And then this is Aviation Week, the source for this article. It assumes you know what rotation's all about. But I went, time out. What is rotation relative to an aircraft's takeoff? Well, rotation during takeoff is a critical moment for pilots. It's when they lift the nose wheel of a tricycle geared airplane off the runway by pulling back on the yoke, raising the elevator, and causing the tail to lower. What you're going to find out, though, what makes this a tricky maneuver is to make sure you don't have the tail of your aircraft smack into the ground by doing it wrong.
I often wonder how they do that.
There you go. So Embraer Enhanced Takeoff System involves a patented software upgrade to the existing flight control system. The company has been working on the software for 3 years, and the system will rotate the aircraft to its maximum geometrical limits while avoiding a tail strike. That's when the back end of the plane, might hit the ground if you take off improperly, right? At the same rotation speeds as would be used for manual takeoff. So it simulates that and makes sure you don't have that tail strike business. Upon lining up on the runway, pilots will select the auto takeoff mode along with auto throttle and engage the autopilot. And this will, by the way, the pilots will still manually correct heading with the pedals if needed. So just like with auto landing, the pilots are not asleep. They're monitoring things. If everything's great with the automatic system, wonderful for landing. Same thing here for takeoff. The takeoff roll is initiated by the pilots by pushing the power levers forward to engage the auto throttle system. So a big innovation in aircraft technology coming to us in 2025, first for the Embraer Brazilian aircraft, but I'm sure other aircraft makers are going to pick up on this and deploy it as well.
Yeah, I am always curious, not always. I've been more curious about aircraft software ever since Boeing has had some trouble with their aircraft systems. And obviously, here in the US, we probably don't get a lot of Embraer, planes and systems kind of coming in and out, maybe the international airports. But I'm curious if other airlines or other airplane manufacturers will see this, try to adapt it, or maybe even license it. Hey, this could really open up, like you said, a lot more larger aircrafts at smaller airports, which would be helpful to everyone. So story number 4. Story number 3. Next is story number 4. And by the way, ladies and gentlemen, I always thought the least flattering image, and for everyone out there who, I don't know, who needs to hear this? When you do FaceTime, don't do it, phone at chest level, looking up at your double chin and up your nose. Raise it just a little bit. Like put the camera above your eye level so it's looking down just slightly. You're gonna look better. Everyone's gonna appreciate it. You're welcome. That's from me to you. But I always thought that was the least flattering face angle. Was kind of the chest view looking up. Turns out. Heat map patterns are the most unflattering facial pictures you can possibly get. But I digress. No, we're going to talk about heat patterns in people's faces and what they could mean for you. This is this is different. Just another indicator of health, I guess. It's interesting.
Oh, it is. This comes from sciencealert.com. This is so interesting, coming out of research from China, by the way. But the headline here is Your Face's Heat Patterns Could Reveal Vital Clues About Your Health. This is so innovative. I love it. And if you have the show notes, you can see the image from the article showing the heat patterns and so on. And this is such a great story. I really encourage you to come out and get the show notes and check this out. There's so many great references. So here we go. A quick scan of your face could one day, this is early research, folks, could one day reveal how well you are aging and whether you are at risk of developing certain diseases. Heat patterns on my face can reveal this? I got to know more. I need to know more. A team of scientists in China from multiple institutions, and in the show note, I have the shopping list of all the organizations involved with this, but we won't read them off. So a team of scientists in China from multiple institutions have found that a comparison of the heat coming off of a person's nose, cheeks, and eye area could be an ideal monitoring and screening tool for healthy aging. Wow. Just let that sink in. I just love it. Anyway, their system trained using facial temperature data from 2,811 Chinese participants between the ages of 21 and 88. Their artificial intelligence program identified several facial thermal patterns, that could hint at a person's biological clock. Okay. You might be thinking, all right, what does that mean? For instance, the temperature of an individual's nose was found to decrease with age faster than other regions of their face. Well, I'm an old guy. Yeah, I guess it's not very warm there. Whereas the temperature...
So when you go up to a dog and you're like, yep, wet, cold nose, they're healthy. It's like the opposite for humans. They want a nice, dry, warm nose. Good to know.
Yeah. So there you go. The temperature of an individual's nose was found to decrease with age faster than other regions of their face, whereas the temperature around their eyes tended to increase with age. I guess that feels... Oh, it is warmer. This means that those who have warmer noses and cooler areas around the eye may have a facial thermal clock that is ticking slower. You have to read the details of the article to fully appreciate this. But then the article is very good because it says, but what does this have to do with a person's health? Help me out here. Researchers found that an individual's facial thermal profile was linked to certain lifestyle factors and metabolic health. Those with diabetes showed a facial thermal profile more than 6 years older than their healthy peers of the same age. Interesting. That's where AI software and its analytic capabilities probably came into play. In fact, the machine learning model, was able to automatically process and analyze a person's facial thermal map to predict if they had a metabolic disorder like fatty liver disease or diabetes with over 80% accuracy. Whoa. Does it replace other diagnostic tools? Of course not. But imagine having this in combination with other diagnostic tools. With a facial thermal scan, you could get a quick little thing and say, oh, there seems to be an indication here of diabetes. Let's go on to the next level of testing. That's the way I see this, as a early first wave kind of analysis, and then go on to other things. Yeah.
Extremely non-invasive and very quick to do.
Good
so
point.
You're right.
Yes. Yeah, imagine you're in a doctor's office, you're having your annual checkup or something, and they go, let's put you in front of this scanner here. Oh, okay. And the AI software immediately says, you might have a liver disease problem or something like that. Yeah,
it's like, hey, we noticed that, you have the temperature pattern over the last 3 visits of this. Let's test for this.
Oh, yeah.
Maybe,
Good one, too. Yeah, you'd have an accumulative history of your thermal facial patterns, too. Yeah, good one. So in the study, those with a metabolic disorder were more likely to show higher temperatures in the eye area than their healthy age-matched and sex-matched counterparts. What's more, participants with the elevated blood pressure showed increased temperatures in the eye area and cheeks. And males with hypertension were typically observed with relatively colder noses. So there's so much more information in the article. Come out to get the show notes at computeramerica.com. Dive in deep if you're in the medical field. This, I think, has some tremendous potential, and salute to our Chinese fellow scientists for figuring this out. Amazing stuff.
It's a fun way that really emphasizes AI in all of this.
Yes,
It's,
yes.
just Ralph, it's just like 3,000 participants. I don't know if they did this over the course of multiple visits or a single visit, or, kind of really how they gathered the data and how they did it. But really, you could not parse and interpret the data, at least not effectively, without AI. And maybe get some of this cool research. So
agree.
Yeah, this could really help. This could have real implications for people, and not just, not just. Yeah. Anyways, it's very, very cool. I like it a lot. So great story. Story number 4. That's great. And for those of you who are following along in the show notes, because by the time that you hear this, the show notes are up and available for you. You may notice that, hey, you guys are not done. Well, that's okay. Honorable mentions. These are stories for you. If you are like, I still got time here on the train. I still got time on my commute. Honorable mentions. These are for you. These are stories that are not worse. They are not less, but they are simply stories we don't have time for. So Ralph's going to give you the headlines, and you can come out to Computer America to get them in the show notes. So please, Ralph.
Yeah, we've got 4 honorable mentions for us today. First one comes from zmescience.com. Headline: This startup is using dead leaves to make paper without cutting trees. And I live in the Northwest in Oregon. We're kind of like New England. We have what I call leaf war season starting in October, when all of my national forest on my property starts dropping tons and tons of leaves, which all get just swept away and put in the recycle. They are recycled. But this company's come up with a way to make paper from dead leaves. Pretty cool stuff. So that one, check that one out when you have time. Another story here from The Cool Down, funny name, but a great resource. Headline: Alaska Airlines reveals groundbreaking technology getting us closer to sustainable flight. It's more watery than we imagined. That's a little fun here. This is a news feature about an all-electric 12-passenger sea glider coming to the market for transportation between bodies of, or like say out to Martha's Vineyard and back and so forth. How about a 12-passenger sea glider? Very cool looking aircraft too, by the way, if you have the show notes. And then the next one is 100% battery recycling could be possible. Researchers at Penn State University have developed a practical method to recycle solid-state batteries. So this applies to solid-state batteries, but it's still a very important recycling story. This comes from the Tech Tribune. And our last honorable mention this week is from newscientist.com. Headline: Tiny jellyfish robots made of ferrofluid can be controlled with light. We've talked about micro robots, organic ones, being controlled by sound and magnetism and other things of this nature. This time controlled with light. How interesting is that? So check this out, folks. Come out to computeramerica.com, get the show notes, and away you go.
It's very, very cool. And you have really highlighted a number of great stories. Ladies and gentlemen, if you want to find out more, computeramerica.com, as Ralph has been saying, and I really appreciate that. And everyone out there, hey, I hope you have a fun weekend. You do something, that's enjoyable to you. And we will catch you here every single Friday with Ralph Bond. Ladies and gentlemen, once again, the show notes, computeramerica.com. With that being said, everyone, be safe, do something fun. And Ralph, thank you for joining us. Everyone, have a good day. Thank you so much. Bye-bye.